Hello grade 10s, welcome back to another exciting video. If you are new here, hey, welcome, and I hope you're doing well. Thank you for tuning in, and if you are returning, hi, how are you? Please consider subscribing to the channel. It's absolutely free to get this type of videos. So in today's video, we'll be doing this KwaZulu-Natal question paper for grade 10 mathematics for March 2024. This was downloaded from the Stanmore Physics website. So this is 75 marks and times is 1.5 hours. So this question paper consists of 5 pages. Now on the second page, the first one is the cover page, and then the second one is instructions and information. So it's very important that when you get a question paper, you go through your instructions and information, and then it says read the following instructions carefully before answering the questions. So instruction number 1 says this question paper, and instruction or information number 1 says this question paper consists of 3 questions, and number 2 says answer all the questions. Number 3 says number the questions correctly according to the numbering systems used in the question paper. So don't come up with your own numbering system, number exactly the way the questions are numbered in the question paper. Clearly show all calculations, diagram, graphs, ECT, which you have used in determining your answer. So with mathematics, it's very important you show your steps so that if your answer is correct, but your steps are correct, your number is incorrect, your answer is incorrect, but the steps are correct, you will be allocated your marks, okay? For the steps. So if it says it's 3 marks, 3 marks do not account for just the answer, but the steps will also get marks. So show all your steps in mathematics. Do that, please, or else you'll be losing out on a whole lot of marks. Number 5 says answer all answers will not necessarily be awarded full marks. That's what I just said. Well, if it's 3 marks, part of those marks go towards steps. So you cannot be given a full mark when you just written the answer. You will be given the mark that the answer deserves. If the answer is 1 mark, then you only get 1 mark, and you have forfeited 2 marks because you don't want to write steps. So number 6 says you may use an approved scientific calculator, non-programmable and non-graphical, unless stated otherwise. So you're going to use your Casio, as is a generally accepted one. So number 7 says if necessary, round off your answer correct to 2 decimal places. So wherever you're working with decimals in this question paper should be rounded to 2 decimal places unless stated otherwise in that particular question. But if nothing was said about rounding in a specific question, then you use the rounding that was given to you in instruction and information page. 8, diagrams are not necessarily drawn to scale. You must know that the diagrams you were given in this question paper are not necessarily drawn to scale. So 9, write neatly and legibly. So we're going to look at this question paper. Here we have question 1. Those are the questions for question 1. That's 29 marks. And then for question 2, there we have, it's like solve for x. And then for question 3, we have trigonometry, okay? So which is 18 marks. So we are going to start this question with question 3. We are going to be starting with trigonometry. Now look at this triangle. It has S at the bottom, at the top, Q on the right hand side, P on the left hand side. The highest, the longest side of a right angle triangle is the hypotenuse. So we also have angle theta at the bottom there, and then the 90 degrees sign to indicate that this is a right angle triangle. All right, so let's draw the triangle. So here we have the 90 degrees here. Sorry about that. Here we have theta, we have S, Q, and P. So that P is the longest side. Okay, so keep that in mind. So we need to identify the hypotenuse. Let's draw another triangle here, which is the one that you get most of the time. You will get theta at the bottom there. This one is a bit upside down. You need to turn it around to be able to see this. So this side that is under the theta, or the theta is sitting on, it's always the adjacent side. And then this longest, the side that is like that S, that's behind the 90 degrees, is the opposite side. Okay, it's always opposite. You go like this. This one that is at the bottom like this, it's the adjacent. So this side is opposite, and then this side that is going down here is the adjacent to theta. So you just draw this when you get your question paper. This is opposite, this is adjacent. So we're going to get adjacent and we're going to get opposite here. And this longest one is the hypotenuse, as we know. So it's going to be the hypotenuse side. I hope you understand and get that, guys. Another thing we have to remember is SOHCAHTOA, meaning sine is opposite over hypotenuse, cos is adjacent over, adjacent over hypotenuse, and then tan is opposite, SOHCAHTOA, opposite over adjacent. So this is what you have to know. Okay, so let's go back to the question and see. So this is the questions: tan theta, negative sine theta, sec squared theta. So we have to write down the values of P, Q, and S in this form. Yeah, now we are here. Number A, set tan theta. Well, tan theta, looking at the SOHCAHTOA, it's opposite, and we said our opposite is the S, so we'll have S over the 10 is opposite over adjacent, so that is 10. I forgot the N there, so just put it there, or let me just say tan theta equals to S over Q. The S is the opposite, and then the Q is the adjacent. And then number B says negative sine theta, negative sine theta is equal, sine is opposite over hypotenuse, so the opposite side is the S, so we're going to have negative S over hypotenuse, which is the P, the longest side. Okay, and then for number C, we are going to have with number C, I have I need some space. Yes, we need some space to do number C. All right, so when you have sec, guys, you are given sec like that. Sec comes from, let's say, when you have cos theta, and cos theta is adjacent over hypotenuse. Sec, on the other hand, will be hypotenuse over adjacent. Let's do this. Let's erase everything. Yeah, for number C, cos theta equals to adjacent over hypotenuse, ne? And then sec theta equals to the opposite, okay? Sec theta equals to the opposite of cos theta. It's hypotenuse on the top and then adjacent at the bottom. And then we can conclude by saying, therefore, sec theta equals to 1 over cos theta. Okay? Yeah. So, that is how you do this. Okay? So, in this instant, you will see that cos theta was going to be P, which is opposite, over Q, which is the adjacent, equals to P over Q. So, sec theta will equals to Q over P. But they said it was squared. Okay? So, we just put the square root there, like when you say Q over P squared. Yes, this is how it is. That's how you're supposed to write it. Let's do it a bit neater. Q over P squared is cosec. So this is how you're going to write it. And then you can also write the final answer as Q squared over P squared. I hope you understand. So we are done with question 3.1.1. All right. 3.1.2 says, if it is given that P equals to 12, the hypotenuse, and theta is equals to 35, then calculate the numerical value of Q. And then we said Q is the adjacent side. So we have hypotenuse and adjacent. So we are going to use cos, because cos is adjacent over hypotenuse. So we will say cos 35, which replaces cos theta, because we were given that theta is 35, so we don't have to write cos theta, we can write cos 35. Or let's say this, cos theta equals to Q over P, that is adjacent over hypotenuse. Then we'll say cos 35, which is the value for theta, it was given to us, is equals to Q over 12. So here you cross multiply. Okay, so it will be as if this is over 1, and then what's gonna happen is that this will multiply by this one at the bottom, and this one will multiply by this one and the top. Okay, so we will have 12 cos 35 equals to Q, because we have multiplied the cos 35 times 12 and the 1 times Q. Anything multiplied by 1, it's still, that thing remains the same. So here we are, and then now what we do is that we will put 12 cos 35 in the calculator. When you put it in the calculator, that will give you 9,829. The instruction says round off to 2 decimal places, so we have 8 here, and then it's 29. 9 is bigger than 5, than 4. Sorry, any number, if you get it was 829. Okay, you are asked to round to 2 decimal places. If this value here it's bigger than 5, it's equal to 5, 6, 7, 8, and 9. This answer, this number, that is the 2 decimal place, has to go up, okay? But if this number is 0, 1, 2, 3, or 4, this answer in the middle, number in the middle remains the same. So because we have 9 there, this will be 3. So this is our answer, 9,83. Yeah, so let's get into the let's look at other answers. Yeah, let's look at 3.2. I'm not going back, I'm not going to come back here. I'm just going to answer them separately. We have that angle A equals to 20 degrees and angle B equals to 55 degrees. Use your calculator to evaluate the following. Correct to 2 decimal places, they have told you here. So we have 3.2.1, that is sine A plus B, and then 3.2.2 is tan squared B, and then 3.2. It has to be 3.2.3, but they said 3.2.2 is 2 cosec A plus sine 5B. So let's do those quickly. All right, so we have angle A equals to 20 and angle B equals to 55. So on number this will be 3.2.1. we have sine A plus B, so that will be sine 20 plus 55. So you just put this into your calculator and you will get 0.97. We are asked to round off to 2 decimal places. I hope you understand this. So I'm just going to erase it and then go on to number 2. And then 3.2.2, we have tan squared B, so that will be equals to tan 55 squared. You punch this into your calculator and then you get 2.04. We're told to round off to 2 decimal places. I hope you get it. So let's erase it to go to the next one. The next one is it's supposed to be 2, not 2. It's supposed to be, let's erase this. We are supposed to have 3.2.3. So that is 2 cosec A plus sine 5B. Okay, so let's do reciprocals. When we have sine theta is equals to opposite over hypotenuse, but cosec theta is equals to, it's a reciprocal of sine, while sec is a reciprocal of cos, equals to the opposite of, which is hypotenuse over opposite. Okay, therefore let me just write, let's say, therefore we can conclude that cosec theta equals to 1 over sine theta. When you see cosec theta, you can still write 1 over sine theta. I hope you understand that. So here we will have, because of this 2 cosec, it's 2 cosec, right, cosec A. So we will have 2 over sine A. We said A is 20, so we're going to write sine 20 plus sine 5 over sine 5, 55. So you punch this into the calculator, then you will get 9,94. Okay, let's look at 3.3. Without the use of the calculator, showing all your workings, determine the value of sine 45 degrees multiplied by tan squared 60 over cos 45 plus sine 30. Write it down because I will not be coming back here. So they will say without the use of a calculator. Here we have sine 45 degrees plus tan squared 60, that is plus sine 30 degrees all over cos 45 degrees. So when in your calculator you punch sine 45 degrees, you're going to get root 2 over 2, and then tan 60 you're going to get root 3, so you have root 3 squared, but when you punch in root 3 squared you will have 3. Okay, we just do it over 1 because the other ones is 2 over 2, so just do this over 1 as well. And then you will have, when you punch in sine 30, that gives you 1 over 2. And then when you also punch in cos 45, will also give you root 2 over 2. So punch this whole thing into the calculator, and then the final answer will be 1 over 2. All right, so I will be doing question 2. We'll start with 2.1. You can write this down, try them by yourself, and then come back for answers. Just pause the video. I'll be doing them on a separate page. All right, so I'm going to start with 2.1.4. These are exponents. So we have 27 to the power of x minus 2 equals to 81 over 2x plus 1. So this is what we have. Now, what needs to happen, guys, is that we need these two bases to be exactly the same. So how can we write 27? The other way to write 27 is to say 3 over, not 3 over, we can say 3 to the power of 3. In your calculator, you can say 3 to the power of 3. 3 to the power of 3, that will give you 27, and then this is equals to 27. And then how can we write 3 as 81? We can say 3 to the power of 4. So just write 3 and try a lot of things. This is equals to 81. So we have 3 to the power of 3 is 27, 3 to the power of 4 is 81. Now we have managed to write these two bases 27 and 81 as small numbers. So we'll have 3 to the power of 3, that will be in the brackets, that is 27 times at the top x minus 2, and then we will have 3 to the power of 4 times 2x plus 1 there. So we will have this x plus this time, we will have this 3 times the x, so we will have 3 to the power of 3x, and then we'll also take this 3 times this 2, and that will be negative 6. 3 times 2 is 6, and then that will be equals to 3 to the power of 4 times 2x, that will be 6x plus 4 multiplied by the 1, and that will be 4. Okay, so we are where we want to be. The bases are the same. Now we rule them out and focus on the exponents. So we'll have 3x minus 6 equals to 6x plus 4. So I'll just write it here. Yeah, let's show it a bit like that. So it's 3x minus 6 equals to 6x plus 4. So we have 3x here, so we can say negative we can move, we need to group like terms. So let's take negative 6 minus 4. What had happened there is that this 4 came this side, so it was positive, now it's negative. That's what happened there. So, and there 6 was still negative, so we have 6x minus 3x. So negative 6 minus 4, that gives us a negative 10, and then negative 6 minus it's not 6, sorry, it has to be 8. Let's do this. Let's do this. Four times 2 is 8, not 6. Sorry about that. This has to be 8x, and then the 4, it's okay. Yeah, so the 4, it's fine there. And then we also need to erase this and this to make it 8x plus 4. So I will erase it here as well. So that is 8x. So we say 8x minus 3, that will give us 5x. So we are looking for x. To get rid of the 5, we divide both sides by the 5, and then that's where we'll have negative 10 over 5, that is negative 2 equals to x. I hope you understand all of this. Very easy busy. Now we can do 2.1.3. we have 2 to the power of 3x minus 1 equals to 64. Now, what you can see is that already we have this 2 as a small number. So we must write this 64 as well as a 2. When you are already given a small number, don't mind it. Write the bigger one as the small number. Okay? So they have to be written as 4, as 2. So that is what you just have to work towards. So here we have 2 to the power of 3x minus 1 equals to, when you say 2 to the power of 6, that gives you 64. So the bases are the same, leave them out, focus on the exponents. 3x minus 1 equals to 6. Now we want to move a bit. So 3x minus 1 equals to 6. So we're going to have 3x, I'll just write here, equals to 6 plus 1. Because this 1 will move this side and will become positive. So 3x equals to 7. So we divide by 3 to get rid of, and then x equals to 7 over 3. Yes, that is the final answer there. I hope you understood that. Now let's go to, oh, it's raining. 2.1 point, hope you'll be able to hear me. 2.1.1, we have x plus 3, and then we have x minus 1 equals to 0. So when you have this, you're going to say for this first bracket, x plus 3 equals to 0, x minus 1 equals to 0. So we will have x, 3 will go to the other side, then it will be negative 3. Then x here equals to negative 1. When it goes to the other side, it's 1. So this is the answer for 2.1.1. And it's raining, guys. Let's do the last one. We will continue this video on the next 1.1. We have 2x squared minus 5x plus 2. If it continues to rain, I will stop. And then we have 2x minus 1, x minus 2. So I've moved too fast. We have this 2x. We can have 2x squared there at the bottom, at the top. So we can have 2x multiplied by this x. They will give you this one. What are the multiples of 2? Two things that you multiply them and we will give you 2. It's negative 1 and negative 2. So, and then you say 2x minus 1 equals to 0, and then 2x equals to 1. Divide by 2 to get rid of the x. So x equals to 1 over 2 in here, and then this side you have x minus 2 equals to 0. So x equals to 2 this side. Watch video. I'm going to link a video in the description box that explains this part, and that explains 2.1.1 and 2.1.2. all right, so here we have our questions, but let's start with 2.3. I'm going to do 2.3 simultaneous equation. So this is equation 1, this is equation 2. So we are going to use the substitution method. Is the easiest. If you know elimination, it's not a problem, but I prefer substitution. It's quite easy. So we need to make x or y the subject of the formula. So we need to find where x or y is by itself. This x is by itself. We don't have another y that is by itself. So I'm going to make use of that one. So I'm going to form equation 3. We're going to say x equals to, we'll take the 3y and negative 5 minus 5 to the other side. So we will have negative 3y plus 5, because the 3y was positive. When we take it to the other side, it's now negative, and that is equation 3. Okay, so what's gonna happen here, we substitute 3 into 1. We substitute equation 3 into equation 1. Wherever you see x, so not equation 1, into equation 2, wherever we see x, we write negative 3y plus 5. So let me just do this in order to get some space. So write this part. I'm just going to erase it. And then that's where we are going to have where we have 2x. This is equation 2 minus 6y plus 2 equals to 0. So we sub equation 3 that we created into 2. So we're going to write 2. Whenever you substitute, use brackets. It's raining, guys, so I'm trying to finish these questions. Plus 5, where we see x, we write minus 3y plus 5 minus 6y plus 2 equals to 0. So you are going to take this 2 multiply by negative 3, that is negative 6y. We're going to take the 2 multiply by 5, then that would be plus 10. And then we take the negative 6y plus 2 equals to 0. Okay, so what happens next is that we take the like terms, negative 6y minus 6y plus 10 plus 2 equals to 0. So negative 6y minus 6y is negative 12y plus 12 equals to 0. So write this step down. I'm going to erase it because I don't have space. I'm just going to erase it so that I can be able to finish this question. So here we have negative 6y minus 6y plus 10 plus 2 equals to 0. So we have negative 12y plus 12 equals to 0. We want the value of y. So negative 12y will equals to 12, and then we divide by negative 12 on both sides. This negative 12 is also negative, so we will get that y equals to 1. Write this step down so that I can show you how to get x. So we are going to go back to any of the equations, substitute y to get x. So we will use that one that say x equals negative 3y plus 5. So x equals to negative 3 into 1 plus 5. X is equals to 3. This is negative 3 plus 5. So when you say negative 3 plus 5 into calculator, it gives you 2. So x equals to 2 and y equals to 1. Now let's look at 2.4. The difference between two numbers is 5. The 6 times is 5, right? 6 times the smallest number is equals to, so 6 times the smallest number is equals to 4 times the bigger number. Find the numbers. So here we are going to let small number equal x or bx, and then let big number equals to y. Okay, and then they say 6 times small number is equals to 4 times big number, right? Before we do that, they said big number minus small number equals to 5, and then they say 6x small number equals to 4 times big number. That will be equation 2, and this will be equation 1. Okay, so we need to find either x or y as the subject of the formula. So we will say y equals to 5 minus x. So where we see y, we will write 5 minus x. Write this step as I'm going to erase it so that we can go to the next one. All right. So let's continue. Now we'll use 6x equals to 6x equals to 4y. So wherever we see y, we'll write 5 minus x. So 6x equals to 4 into x plus 5. Okay, so that is how we'll write it. And then we will have here 6x equals to the 4 times the x, it's 4x. The 4 times the 5, it's 20. So we have 6x minus the 4x equals to 20. So 6 minus 4, we will have 2x equals to 20. We'll divide by 2 to cancel that. And then x equals to 10. Okay, so we need to find y. We can use this and then substitute. We'll say 6, 10, substitute x as 10 is equals to y. So I hope you wrote this step down because I'm going to erase it. Now we will have 6 times the 10, that will be 60 equals to 4y. We'll divide by 4 on both sides, and 15 equals to y. If you are finding this video informative, please don't forget to subscribe and like this video. It helps the channel to grow. So please guys, like the video. Let's look at 2.5. If p is equals to 1 plus 3 to the power of x, and q is equals to 1 plus 3 to the power of negative x, prove that q equals to p over p minus 1. All right, so p equals to 1 plus 3 to the power of x, and q equals to 1 plus 3 to the power of negative x. So q equals to p over p minus 1. So here we're going to have 1 plus sp 3 to the power of x, and then we are going to have 1 plus 3 to the power of x. Remember the exponential signs rule say when you have a negative exponent, you can write it as 1 over 3x and it will be positive. Hence why this one here is positive. The x, we don't have minus. Okay, so don't ask yourself what has happened there. That's what took place. This here is now positive because it's on the bottom. Here it was on top, now it has been taken at the bottom. Okay, and then we will have the minus 1. So at the bottom we have 1 plus 3 to the power of x minus 1. So the 1 will minus the 1, and then we'll have 1 plus 3 to the power of x over 3 to the power of x. So this can still be written as 1 over 3 to the power of x plus 3 over x to the power of 3 over x, because this one can also be taken here. When the bases are the same, you are adding, you just take one base. Yeah, so I hope you know about lowest common decimals and stuff like that. So this will be this one. Remember that exponential rule, that when you have you can write it as 1 over 3x. So here we're going to be x minus 3 plus 1. So the 3 to the power of x divided by 3 to the power of x, and that will give us 1. I hope you understand this question, guys. Yeah, finally done with question 2. Now let's go to question 1. Guys, I'm not going to do 1.1, 1.2, 1.3, 1.4. No, I'll just do 1.4 and 1.5 in this question. So let's start with 1.5. Okay, 1.5.1 to 1.5.4. Write them down, do them, and come back. Let's mark them. All right, this is 1.5.1. We have 2x minus 1 into 2x squared minus 2 plus 1. Okay, so we're gonna be multiplying these two brackets. So we will have this 2x minus this x squared, so that will be 2x multiplied by x squared in the brackets minus the 2x multiplied by negative 2 in their own bracket, and then also the 2x multiplied by 1, so that will be 2x, it will be plus, because this is a plus here, this is a minus, that's why we have a minus there. Yeah, so we'll have plus 2x plus not plus, multiply by 1. Here also it's multiplication, sorry. And then we have multiplied the 2 with that bracket. Now we multiply the 1, so that will be negative 1 multiplied by x squared, which is with this negative 1 multiplied by this x squared, and then we will have a negative 1 multiplied by negative 2, and then we will have negative 1 plus 1. Okay, so we are going to have 2x multiplied by x squared, so we're gonna have x2, we add the x's, so it's 1 plus 2, this one has to the power of 1, and then that will give us 2x to the power of 3, and then that will be minus 2x, this 2x, this 2x, this ones, we have 2x times 2, and that will be we have 2x minus 2, that is negative 4x, and then we will have plus this 2 minus that one, that will be our 2x as well, and then we will have negative 1 minus x, so that will be negative negative 1 times x squared, that will be negative x squared. And then we will have negative 1 times negative 2. In your calculator, it's negative 1 minus negative 2. And then that will be plus 1. And then we will have negative 1 times negative 2. Negative 1 times positive 1. And that will give us a negative 1. I made a mistake on the question here. Sorry about that, guys. This is 2x plus 1, right? So we have x squared minus 2x plus 1. So I only written 2 there. So this times this, well, 2 times 2x minus 2x squared. So we have the 1 here. So that will be the x time, the 2 times the 1, that will be 2. And then those x's, the bases are the same as the exponents. This one is to the power of 1, then 2, then we have 3, and then we have 2 times negative 2, that is negative 4, and then we have x to the power of 1. We have x to the power of 1 there, so that will be x squared. Then we will have 2x times 1, that will be plus 2x. And then we will have 1 times x squared, that will be a positive x squared. Then we'll have this 1 times a negative 2x, and then that will be that will give us a negative 2x, and then negative 2x. Yes, and then the 1 will multiply the 1, then we'll have yeah, I think I'm just tired now, because he's supposed to be minus 1, and then here as well will be minus 1, and then here as well will be a minus x. Yeah, just tired now. So let's group the like terms. So 2 to the power of x cubed is by itself. Then we have negative 4x squared minus x squared. Then that will give us negative 5x squared. Then the other, this is the like term by itself, so we'll try to find another like terms. The other like terms that we have is 2x minus 2x, and that will give us plus 4x. And then this minus 1 is by itself, so we cannot simplify any further than this. Now let's do another one. Let's do 1.5.2. so we have 3x plus 5. What we are doing is called the distribution method. So here we have 3x plus 5 squared. So when you write that, you expand it. You said 3x, it means 3x 2 times 3x plus 5. This is how we do it. So you say this times this is 9x squared, and then we say this one times this one will be plus 15x, and you do this with this one as well, and then that will be 15x, and then you will have plus 25. Then you have 9x squared. 15 plus 15, that is 30x plus 25. So that is the answer. Yeah, I'm just going to erase it to move on to the next question, which is 1.5.3. All right. Here we have 1.5.3. We need to solve this. So we'll say 2 to the power of x minus, remember, when the bases are the same, 2 to the power of x multiplied 2 to the power of -2, we add the exponents. Okay, the bases are the same, so we just say x plus -1. So that's what happens there. Or when we have 4 divided by 4, the bases are the same, we subtract the exponents. Okay, so this is 4 to the power of x and then 4 to the power of -2, or we have it like this: 4 to the power of x and then 4 to the power of 2. The bases are the same, we multiply the exponents, so that will be 4x minus 2. See, this is what happened here. Okay, the bases were the same, and there was a division sign in between, so we just subtracted the exponents. So that will be, we'll write them as 2x 2 -2, just like that, and then that will be over, yeah, so that we can just do it over and that will be over 2x times 2 minus 2 to the power of x. So if you look at it, we had 2 plus 1 and then 2 to the power of x, so we just brought it 2 to the power of x that side, so this to the 2 to the power of x, we just have 2 to the power of x times 2 to the power of 1 is 2 to the power of 1 minus 2 to the power of x. Remember, the bases were the same, we add the exponents. Okay, 2 to the power of x minus 2 to the power of 1 equals to 2 to the power of x plus 1. Remember that, guys. I'll show the full step. Now, the next step that will be taken is take out a common factor. So we have 2x squared, 2 to the power of x, 1 minus 2 to the power of -2. At the bottom, let me write it and then I will explain it nicely to you guys. Then at the bottom, we'll have 2 to the power of x as well as a common factor, 2 minus 1. I'm going to leave a link to the video where I explained this in detail. Remember to check it out. So here we have 2 to the power of x minus 2 to the power of x times 2 to the power of 2. Okay, so what happened there is that we have 2 2's to the power of x. So we take one of of those 2 to the power of x outside to get a because it's a common factor, this one and this one, we took them outside. Okay, and now we inside the bracket we have 1 and the 2 to the power of 2 at the top and the 2 to the power of 1. We can still say 2 to the power of 1 here. Okay, this 2x minus this 2 to the power of 1 will give us 2 power of x, 2 to the power of 1, and then this 2x plus this 1 will give us 2 to the power of x. You see, it will still give us what we have at the top. That is how we did that. Even this one's on at the top, when we take this 2 multiply by this 2, we'll have 2 to the power of x multiply by 2 to the power of negative 2 multiply by 2 to the power of x. We still have the same thing, but I'm going to link a video down below on the description box that you people can go through. Now, since we are at this step, the next thing to do is to cancel common ones. So this and this will cancel, and then in your calculator you will punch in 1 minus 2 to the power of negative 2 over 2 to the power of 1 minus 1, and that will give you 3 over 4, and that is your answer. I hope you understand this. All right, here we have 1.5.4. So oh, this is the answer part. Here we have a squared minus a minus 12. Okay, so we are looking for the LCD. Whenever you see this, you must factorize, meaning you must have 2 brackets. Okay, this is, we have a, this is a, and then this will have a. I'll link a video in the description box that explains this. So you need to look for the multiples of 12, that when you add them, when you multiply them, they give you 12. That is 3 and 4. But when you add them, they give you 1, which is 1a. So that is what you have to look for. Now we have a minus 4 and a plus 3. So those are the factors. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So that is how we found these factors, but I will leave that in the description box down below. So when we have this, we must factorize this. So the next step will have 3 over a minus 4 plus 2 over a plus 3, and then minus 21 into a minus 4 into a plus 3. So you have to make all the denominators the same way. So we'll say LCD. We have here, we have a minus 4. This is a plus 3. This is, we have a minus 4 and a plus 3. So LCD will be a minus 4 and a plus 3. Okay, so we need to add on 3 over a minus 4. We need to add a plus 3 because it's not there. A plus 3, we multiply it by this, and then this one we multiply by a minus 4. But the 12 over a minus 4 already has the LCD that we need, so we don't need. Whatever you do at the top, you do at the bottom. So we'll multiply by a plus 3. This will multiply by a minus 4 because we don't have minus 4 here. So that's how you will do it. And then we are now going to have something like this. 3 into a plus 3 plus the 2 into a minus 4 minus the 21. It doesn't need that. So we'll have a minus 4 and then a plus 3, the LCD. Okay, so we'll have multiply the brackets. We'll have 3a plus 9 minus 2a minus 8 minus 21 all over a minus 4, a plus 3. Okay, and then the next step, the like terms here that we can add them together is negative 3a minus 2a. We can do that calculation. We can also say 9 minus 8 minus 21. So we'll just take it like that. Let's erase what we had written previously, and then that will give us, we'll have 5a minus 20 all over a plus 4 all over a plus 3. Okay, that is what we can have. So we can factorize the 5 minus a. We'll take 5 outside. We'll have a inside. For us to get 20, we can say 5a minus the 4 all over a plus 4 and 9 plus, not 9, a plus 3. Sorry, this is a minus 4, so these ones will cancel each other. Then we'll have 5 over a plus 3 as the final answer. I hope you get this. Please subscribe, guys. We're almost there. We left with 3 questions. All right, now let's look at number 1.4. We have 1.4.1 to 1.4.3. Here you were asked to factorize. Okay guys, this video is too long. Let's meet on the second video where I'll be going into detail with factorization. So I'll be teaching you guys how to factorize, and we'll tackle these 3 questions, and that video will drop tomorrow, exactly the day after this one. So check that out. It will be the video after this one. Yeah, I don't want it to be too long. So thank you very much for watching. Until the next one.